sorry. This is 2.41, cost of breakfast. Sally gets a cup of coffee and a muffin every day for breakfast from one of the coffee shops. She picks a coffee shop every morning at random and independently of previous days. The average price of a cup of coffee is $1.40. Okay, so it looks like they're telling us things like we have stuff for coffee. So for coffee, we have the average. Now, average tells you expected value. So the expected value for the coffee equals 1.40. The standard deviation for the coffee, it tells us, is 0.3. It doesn't tell us the variance, but we'll need that. So the variance would then be 0.3 squared, which equals 0.09. Now, it tells us that we have a muffin, and it has an average cost, or expected value, of 2.5, and the standard deviation is 0.15, and it doesn't tell us that, but we can find the variance just by squaring it. So the variance would just be 0.15 squared, which equals 0.0225. Notice it told me things like I have some existing stuff, and it told me their means and variances. It didn't give me a bunch of x values and the probability for each x value. So to me, this seems like we're going to be doing something dealing with the rules for combinations of random variables. We already have our random variables. We already have their expected values and variances. Now we're just going to combine them some way. So A says, what is the mean and standard deviation of the amount she spends on breakfast daily? So every day she gets a coffee and a muffin, and they don't affect each other. It should all be random. So we're going to say for each day, it should be a coffee plus a muffin. So we're making a new random variable. We want to find the mean and standard deviation. So to find the mean, that means expected value. So we'll find the expected value of a coffee plus a muffin. Well, expected value rules say you can just find the expected value of each one of these individually. So the expected value of the coffee is 1.4 plus the expected value of the muffin, which is 2.5, and we get 3.9. So we'd expect that each day she should spend about, on average, about $3.9 a day. That's just the average. For the standard deviation, well, first, before you can find standard deviation, you have to find variance. The formulas only work if you find variance first. So we'll find variance first. We'll do the variance of a coffee plus a muffin. Well, variance rules say you can also just add up each of the individual variances. So we'll do variance of the coffee plus variance of the muffin. So variance of the coffee was 0.09 plus variance of the muffin of 0.0225 gives me 0.09 plus 0.0225, 0.1125. So the variance will be dollars squared, $0.1125 squared. Now for your standard deviation. So the standard deviation of a coffee plus a muffin is just the square root of what you got for variance. So square root of 0.1125 is 0.3354. So now we found the standard deviation would be about 33 cents. So again, this is one where you started off knowing some means and variances and then use your rules for combinations. Rules being expected value, if you're adding two things, you just add each one individually. Variance is also the same rule. Now, next part, what is the mean and standard deviation of the amount she spends on breakfast weekly? This one you do have to set up carefully, because some people might try to do like 7C plus 7M or something. That is going to be wrong. She did not go to the same place 7 times, or she didn't buy the exact same thing 7 times. So it's not 1 cup of coffee times 7, because again, it's not exactly the same thing 7 times. Instead, it's going to be your first cup of coffee plus your second cup of coffee plus your third cup of coffee plus your fourth cup of coffee plus your fifth plus your sixth plus your seventh, plus now you'll do 7 different muffins. Now, because each muffin is going to be different, you have to actually do each of the 7 muffins added together, because each one should be different. We don't just times it by 7. But because you're just doing addition, all of these rules will be exactly the same. So to find the mean, you'll just add up the mean for each one of these. And to find the variance, you'll add up the variance for each one of these. So go ahead and try that for part B, and you should be able to go check your answer. I'll update it on Canvas as well.